Let's start with the drawbacks of Rutherford atomic model. Well, and also about Planck's quantum theory. Well, it was quite shocking. Rutherford, for heaven's sake, Rutherford, he couldn't explain the stability of atom. How is it possible? Well, dear Rutherford, look at the kind of photons, the energy which is emitted from that electron. How can you possibly not explain that? And more adding to it, the second drawback was, according to the classical ancient age theory, an accelerated electron must give rise to continuous spectrum of continuously increasing frequency and decreasing wavelength, somewhat like this. Rainbow was expected out of it. But dear Rutherford, in reality, the spectrum is not like this. It's this. Where are the remaining lines? And why are there only few lines? Well, Rutherford, there are much more things to it. You assumed circular motion of electron is an accelerated one. But in reality, my dear friend, it is just a stable. And acceleration charges, they loses energy. But my dear friend, in real sense, it doesn't lose any energy. Energy, if it is released continuously, the entire energy decreases. But here, energy remains constant. Energy and the electron must follow a spiral path. If it goes spiral path, it will go inside the nucleus. It follows a circular path. And finally, it falls inside the nucleus. No, it never happens. So this is what your assumptions were. This is the reality. And this is the whole idea. One is going inside, another is going here. Now, who will be there to answer these queries? That will be followed in the next module. But dear students, it's a systematic way of understanding where Rutherford actually failed. But even though he failed, he was creator of the new atomic model. And that's what we have to appreciate him for. So that's what Rutherford really was. Yeah, man, you rock. Now, let's come towards a beautiful and amazing theory by a very famous mathematician called Maxwell. Quite a fellow, eh? And then there was a Planck. Quite a fellow, eh? So basically these two giants, they came up with their own theory. Maxwell told energy is emitted in terms of electromagnetic radiation. For example, light. Light is a wave. Everything is a wave. UV is a wave. And that's what we can expect, such kind of dispersion of light, which you have studied in your lower grades. But Planck was like, no, radiation is in terms of particles. And these particles are called as photons. Let's have a look at this video, shall we? So as you can see, these are the atoms. The small dots are the electrons. When the electrons come out, there are the photons which are emitted. The shining lights are the photons. And that's how you can see the entire atomic structure is based upon. Now Planck had his grip on Rutherford. He told, my dear Rutherford, energy is absorbed or emitted in terms of discrete packets called bundle or photon or quanta. Well, for that bundle, the energy is h into its nu, where h is called Planck's constant. Of course, he gave the theory. Nu is called the frequency. Energy depends on frequency. And frequency is c by lambda. So h is equal to, it was a constant. Please remember the value. It's 6.63 into 10 raised to minus 34 joule into second. Why joule into second? H is equal to E upon nu. E is joule and nu is 1 upon second. So it is joule into second. Easy peasy, nice and peasy. So here we have Planck. He says, science cannot solve the ultimate mystery of nature. Yes, my dear Planck. And that is because in the last analysis, we ourselves are a part of nature and therefore a part of mystery that we are trying to solve. Amazing philosopher, amazing guy. Thank you, Planck, for bringing the quantum physics into picture.